looks the same as it always does.
What does that mean? It doesn't look good.
What? No, it's great.
Thank you.
Oh, the camera's on.
What?
The camera's on.
The camera's on? No more questions. Okay, so we successfully made a hypothesis and identified our variables. Now we're ready to carry out our experiment. But wait, what tools do I need? How will I collect, measure, and record my data? What does data even mean? How is it that there are this many questions in a scientific investigation? I just want to have fun.
Well, to borrow from Mythbusters, the only difference between science and fun is writing stuff down. And you gotta write stuff down.
In all scientific investigations, scientists need to obtain information. To do this, they make observations. An observation is the gathering of information using the senses, or with technology that enhances the senses. Scientists then take these observations and write them down nice and neat during their experiment. This is called data collection.
So what's data? Data, or more accurately, a data set, is really just information. It's the information you get from observations, reasoning, calculations, or anything that's detected from an instrument, like, for example, a thermometer. For example, if you were observing how fast someone ran around a football track, the data you collect would be the time it took in seconds. Measurements and calculations are called quantitative data, anything dealing with numbers or quantities of something. If you were looking for a chemical reaction occurring in a substance, you might look for a color change, bubbles, or even a smell. That kind of data is qualitative, dealing with qualities, descriptions, or characteristics.
Earlier, we made 3 different hypotheses. Drinking more than 1 cup of coffee will increase comprehension performance, decrease comprehension performance, or have no effect on comprehension performance. The only way I will know which hypothesis will be supported is by looking at the data. So, how do you collect your data? Well, making neat organizers, tables, and charts definitely help. Have a look here at this neat table. If I jot down my data here, I can easily read it and access it any time. According to the data table, 50 people will participate. I will give them each 2 passages to read and to answer questions at the end of each passage, 1 at 5 p.m. and 1 at 6 p.m. For my control group, 10 people will not drink coffee at all before their test. For my experimental groups, they will all read and take the first quiz without any coffee, but before the second quiz, they will each drink different amounts of coffee. You'll see here, my first experimental group will drink 1 cup, this one drinks 2 cups, and so on. And there's even an easy way to remember what you should be looking for when collecting data. Remember our independent and dependent variables? Well, that's what we generally use when looking for data. I've labeled this column in the table, our independent variable, in my case, the number of coffee, and over here on the right, the dependent variable, which will be the average of all the quiz scores I will collect. I will also label my columns with their proper units.
Yes, please don't forget to include your units. Remember, a number doesn't have a whole lot of meaning without the proper units. Did you know light travels 186,000? What, seconds per hour? It doesn't mean anything. It sounds strange without any units. It's 186,000 miles per second. Whoa! Anyway.
So the next time you say that your teacher is really neat, or is too neat, or is constantly reminding you to write down proper units, or to use a ruler, or has OCD issues, remember, it's all in the name of science. And cut. Hey, you have a mirror in your room? I'm feeling the poof today. I'm a little de-poofed.
That makes 2 of us. Your poof is like, it's got a little.
I need more poofage.
You got, yeah.
Okay.
You're not at maximum poofage.
All right, that's a wrap, everybody. Mirror.